So our goal today is going to be to construct parallel or perpendicular lines. So the first thing that we're going to do is we're going to construct a line parallel to line M. So here's line M that passes through point P. So you can kind of visualize what this would look like. It would look something like this. Can you kind of visualize that? Well, now we actually have to construct it. But what we're going to do is we are going to make it so that we construct a congruent angle. What angles would have to be congruent in order to have parallel lines? What kind of angles would have to be congruent to have parallel lines? What have we been working on in the last week? Huh? What kind of angles would have to be congruent to then have parallel lines? Corresponding angles would have to be congruent to have parallel lines. Or what else? Go ahead. Alternate exterior, alternate interior, or? Is that what you're going to say? Yeah. So what we're going to do is the first thing we're going to have to do is we have to draw a transversal. So you're going to draw that transversal, and now you have 4 angles down here. Okay? I tend to do corresponding angles every single time, so I'm not switching things up. So what you're going to do is you're going to start with a transversal. Okay? Now the directions are in your packet on the back of that puzzle sheet. Okay? That puzzle sheet that was only one-sided where you could paste your work on. The written out directions are on the back of that if you need to reference them. Okay? So start by drawing the transversal. Then you're going to put the point of your compass on the vertex of this angle. And we're going to make an arc fairly large. I usually put it right through that point P or a little bit before it. So you want to make it as large as possible without going beyond it because we don't want overlapping arcs. So I made an arc there. Now I use the inside hole for that, so I'm going to come up. I'm going to put my point on P, and I'm going to copy that exact same arc. Hold on, let it refocus. There you go. So I made the arc down here. I put my point here, made an arc, slide your point up to P, make the same exact arc. Then what I'm going to have to do is if you put your point on P, or wherever that arc is meeting, I put it through P. So put your point on P, and what you're going to have to do is you're going to have to adjust your compass to measure that arc. Once you've measured that arc, you're going to go up to the next intersection up here, and you're going to copy that measurement on the arc. Okay, I'm going to walk through it again. Okay, I put my point on the transversal meets the first line. I drew an arc. I came up to where that arc meets that line. I copied the same arc. Then I moved my point to P, and I had to adjust my compass to measure that angle, measure that arc. How far down that arc did the angle meet? Then I moved my point up to this intersection, and I copied that arc. Where those two arcs meet, that's where that angle is formed. Okay, what I did was I constructed this angle and this angle to be congruent. Since I constructed those corresponding angles to be congruent, I know that those two lines must be parallel. So I constructed those to be parallel. Okay, I told you guys there's a lot of steps here. We'll go through it again. Okay, so the next one you're going to go through R. So here's your transversal. I'm going to start by drawing a transversal here. So the transversal just has to go through R and go through that other line, because we can kind of imagine where this is going to be. And some people turn their paper so it's the same every single time. So just have it so that that looks flat to you. So the first thing you're going to do is you're going to draw in that transversal. Are we okay with that part? We're going to put our point on this intersection. We're going to make an arc. We're going to slide up to R and make that exact same arc. What's the problem with my diagram right now? Anyone see it? See how my arc doesn't meet my line, my transversal? I am going to have to use my straight edge and actually extend my transversal, because it is important they do have to meet. Okay, there we go. All right, so I've had my point here. I made an arc. I moved it up to R. I made the same arc. Now what I'm going to have to do, again, this first arc did not have to go through R. If you wanted to make it go through R, that's totally fine. I'm going to have to measure that arc right there. Then I'm going to have to measure and copy that arc over here. So I'm going to come up to this intersection. I'm going to copy that measurement. And now R, and that point there, will make parallel lines. Why does it make sense to copy an angle to get a line parallel to line M? Why does it make sense to copy that angle? We already kind of mentioned it. Why does it make sense to copy an angle?
K through R.
So why does it make sense to copy an angle to get a line parallel to M? What says, if such and such angles are congruent, then the lines are parallel? What is it? If corresponding angles are congruent, then lines are parallel. What is that? What says if corresponding angles are congruent, then lines are parallel? What is that phrase? What do we call it? What says if corresponding angles are congruent, then we have parallel lines? The corresponding angle converse. Good. The CA converse. The corresponding angles converse states that if you have corresponding angles that are congruent, then the lines are parallel. And because of that, we can construct those congruent angles, and it will create parallel lines. Is it possible to construct a line parallel to a given line M that passes through a point P that's on line M? So let's kind of draw this. So we have a line M here, and it says that P is on line M. Would it be possible to construct a line parallel to M that goes through P? No, because P is on the line M. And if you draw another line through P, it would have to intersect M because it's on M. And parallel means that they never intersect, so that would not be possible. Okay. Okay. All right, let's flip this over. And it says to construct a line parallel to line N that goes through R. So I want you guys to try this one on your own. Okay, these next two I want you to try on your own. I will give you guys a couple minutes to work on that. Okay. So here are our parallel lines. Should look something like this. Okay. So next we're going to construct a perpendicular bisector because that was review. Does anyone remember how to construct a perpendicular bisector of this line? Go ahead. Uh-huh. Okay, so you go from one point and you make an I-shaped thing, so an arc, right? And then you go to the other end and you make the same exact arc, right? So we have to go further than halfway. If you went all the way, that's fine, but I have a feeling this one would go off the paper. So you just want to make sure you're beyond the halfway point. So draw the arc. Then we're going to slide to the other end point. And draw in that same exact arc. What's that? Nope, you put your point on one end, draw the first arc, move your point to the other end, draw the other arc. But the arc has to be opened up, it has to be beyond the halfway point. Otherwise, these won't intersect. It doesn't matter exactly how far you go. Yes? Go past. Okay, so then we take our ends of that loop-de-loop and you connect them with a straight edge. And this line that is intersecting that segment is perpendicular and it bisects that segment. So this point right here is the midpoint of that segment. It's going through the middle of that segment. Is that okay? So we're going to do something very similar.
Any freshmen that leave?
Okay, so the next one, what we're going to do, and for whatever reason, I always like the point to be under the line. It does not matter. But what you're going to do is you have to, this is a line and it's not a segment like this one was. So what we're going to have to do is you're going to put your point on P and you're going to make like what looks like a horizon, like a sunrise. Like a horizon. And that's going to create a segment like that. And now that we have the segment there, so you're going to pretend there's nothing else, there's that segment. Now we can draw a perpendicular bisector of that segment. So you put your point on P, it looks like a little sunrise. That's I think part of the reason why I like to put it so that the point is always underneath, because then it always looks like that horizon. Like the sun is setting or the sun is rising, whichever one you want to, glass half empty, half full, whatever you want, right? Okay, so then what we're going to do is we're going to create that loop-de-loop from both endpoints. So we're going to put our point here and then our point here, and we'll draw the loop-de-loop from those 2 points. So our point comes here. If you want to go all the way to the other point, you could do that. If you want to go just so like 3/4 of the way, you could do that. So there's the one loop. Come to the other end, point. We're going to draw that exact same loop. They meet up here and they meet down here. If they did not meet, you might have to go back to that point and make the arc a little bit bigger. Now that you have both of those, what you can do is all 3 of those points should be collinear. And when you connect them, you should notice that it goes right through P. It should appear to be perpendicular to that line that was originally there. Okay. It is directly in the middle of those 2 points. That's why we had to create them, because we know how to do a perpendicular bisector. Okay. I'll do another one with you right here. So I'll put my point on R and I'll start with that horizon. So there's that horizon. There it is. You can see the endpoints now. Put your point on one of those endpoints. Draw your first arc. Move it to the other end point. Draw that same arc. If it goes off the paper, you're going to have to draw new arcs that don't go off the paper. And then you should be able to connect R and those 2 points. They should all be collinear. And there you've constructed a perpendicular. Hold on, let it refocus. There we go. We've constructed a perpendicular that goes through R that's perpendicular to that line N. Okay.